Algebra 2 6.4b, divide a polynomial by a polynomial. In our last video, 6.4a, we divided it by a monomial. And if you've missed any of the previous 7 videos, you need to go into this description and watch those. You might become lost or confused. You can just click on the links. So remember, fractions are little division problems, and rational expressions are also division problems. When the divisor is not a monomial, like our last video, we use a method that's very much like long division. And sometimes our polynomials will have missing terms or one missing term. We can use a 0 as a placeholder when this happens. We can check our answer by multiplying the quotient by our divisor, just like we do in long division. And polynomials should be written in descending order with spaces for our missing terms in the dividend. Or we can use the 0 like I mentioned before. So descending order means that the exponents are going to slowly go down. So we'll have x to the third, then x to the second, then x to the first. In ascending order, they go up. X to the first, x to the second, x to the third. So we're going to use the top one. And if there's any missing ones, we'll put 0x to the second or 0x. And I'll show you. Okay? So this is just like long division. And if we have 67 divided by 5, the 5 is the divisor, the 67 is the dividend, and we have 13 for a quotient. You can see we have a 2 as a remainder, and it can be written as a rational expression or a fraction by writing our remainder over the divisor as 2/5. And we're going to do that, and I'll show you, okay? So this is actually a closed parentheses and a fraction bar or a vinculum. It's not actually one symbol. It's actually 2. But we can call it a division bracket to make it easier, okay? So we're going to divide x squared plus 5x plus 8 by this divisor x plus 3. We put it inside of our division symbol, and here's the dividend, here's the divisor. And the first thing we're going to do is we're going to ask ourselves, what times what is going to give us this x squared, this first term and this first term? X times what is going to give us x squared? So you can look over here to follow me along on the side. I'm going to have all my instructions. We've got x times x would give us x squared. Now we have to multiply this pink x by the 3. We can't forget this second term, and that gives us a 3x. This is eliminated as additive inverses, a 0 pair, and this gives us a 2x. We drop down the 8, and now we ask ourselves again, x times what would give us 2x? A 2, so it goes up there with the quotient. This creates another additive inverse 0 pair, and 8 take away 6 is 2. Our remainder is 2. So our quotient is x plus 2, remainder 2. We can check it by multiplying. We'll multiply x plus 2 times x plus 3. We can FOIL, and when we do and combine our like terms, we get our original dividend, x squared plus 5x plus 8. See? Then we know we did it right. All right, I got a few more examples for you, okay? So I want to stand back far enough so you can see everything. So here's all the instructions of what I'm doing, and I've tried to color code them as best I could. Here's our dividend, here's our divisor, and the first thing we're going to do is we're going to ask ourselves 5y, this first term and this first term, 5y times what would be 125y to the third? Well, it would be 25y squared, so that goes up there with the quotient. We multiply them and get our 125y to the third. But now we need to multiply the second term by that pink 25y squared, and we get a negative 50y squared. This is additive inverses. It's eliminated as a 0 pair, and 0 minus a negative 50y squared. When you subtract a negative, you add the opposite, and you get a positive, don't you? So we have 50y squared. It's the 0y's turn to come down, and you see that we were missing the y to the second and the y to the first, so I put in 0y to the second and 0y to fill its spaces. See that? And this is another additive inverse. It's gone, and as a 0 pair. And now we have 0 minus a negative 20 gives us a positive 20y. It's the 8's turn to come down, negative 8. Now we ask ourselves again, 5y times what is 20y? Well, that would be a 4, okay? So now we're right here, and we have 20y take away 20y, that's eliminated, and we have a negative 8 minus a negative 8. We add the opposite, so we have negative 8 plus 8, that makes a 0. So we have a remainder of 0. So our quotient is 25y squared plus 10y plus 4, with a remainder of 0. See? So just remember, if you're missing any terms, you can just fill them in with a 0 as the coefficient and that variable, okay? It really helps. All right, so we're going to do it again. We've got x to the 4th minus 9x squared, but there's no x to the 3rd, is there? There's no x to the 1st. So we're going to fill in a 0x to the 3rd and a 0x in between here where they should have been, okay? We're going to write our dividend and our divisor, and we're going to do the same thing we did before. We're going to ask ourselves, with this first term and this first term, x times what would give us x to the 4th? That'd be x to the 3rd. We do the multiplication and get our x to the 4th. We do our multiplication for the second term, x to the 3rd minus negative 2, and get negative 2x to the 3rd. That is an additive inverse, so the x to the 4th is gone. And remember, when you subtract a negative, you add the opposite. So we've got a positive 2x to the 3rd. Now, if you've noticed all along, my exponents are lining up. Here's all the 4ths, the 3rds, the 2nds, and in every single one of them, here's x to the 2nd, x to the 1st. I'm always lining them up, aren't I? All right, so now we're right here, and we have to ask ourselves, it's the 9x squared's turn to come down also. We ask ourselves, x times what is 2x to the 3rd? That would be 2x to the 2nd to get 2x to the 3rd, wouldn't it, for that x? Now we have to multiply this 2x to the 2nd to that negative 2, and we get a negative 4x squared. This is eliminated as an additive inverse, a 0 pair, and a negative 9x squared minus a negative 4x squared. We're going to add the opposite again and get a negative 5x squared. Now it's the 0x's turn to come down. We ask ourselves again, x times what would give us a negative 5x squared? It would be a negative 5x, wouldn't it? And we multiply the negative 5x times the x, we get negative 5x squared. We multiply the negative 5x times the negative 2 and get a positive 10. Okay? This is eliminated because we're adding the opposite. We're going to end up adding a 5x squared, so that's gone as a 0 pair as additive inverses. And when we have a 0 minus a positive 10, we get a negative 10x. It's the negative 5's turn to come down. This is eliminated as an additive inverse because we're adding the opposite, so it's a positive 10 from a negative 10, that's a 0. And this negative 5 take away a positive 20 is a negative 25. We can write this negative 25 over our divisor as a rational expression, and our quotient is x to the 3rd plus 2x squared minus 5x minus 10 minus, because that's a negative, minus 25 over x minus 2. See? So I got one more example for you, and instead of putting a 0 for the missing space, we're just going to leave the missing space. Okay, let me show you how we're going to do that. So, and notice in this one, we've got an x squared for our divisor. Okay, well, when we have exponents in the divisor like that, when dividing, we keep going until the degree of the remainder is less than the degree of the divisor. So we want to keep dividing until our remainder is smaller than that. See, this is x to the 1st, so that's good. We can't stop here because we're still at x to the 2nd. It's not smaller yet, see? All right, so the degree of the remainder has to be smaller than the degree of the divisor. And our answer can be written as a quotient. We just saw that. And remainder, or as a polynomial plus a rational expression. So we can either leave it as a 2 like we did here, or we can write the remainder over the divisor, can't we? So we need to divide this polynomial by this polynomial. And now this has got an exponent, okay? So instead of putting a 0 in the space, right here we've got x to the 3rd, x to the 2nd. There should have been an x to the 1st, but we don't have one, so we're just going to leave a blank space here this time, and then put our minus 5 at the end, see? Because it should have been in between the 9x squared and the minus 5, so we've got a big empty space, okay? So now we're going to do the same thing we did before. We've got our first term and our first term, and we ask ourselves, what does x squared need to be multiplied by to become an x to the 3rd? Just an x, so we put it up here. When we multiply them, we do get our x to the 3rd. And then we have to do it to the second term here. X times negative 1. We get a negative x. And because we want to line up our exponents, it doesn't go here, it goes way over here where the x of the 1st should have been. We drop down this 9x squared, and because we're subtracting a negative x, we're going to add an x. See? It's adding the opposite. And then it's the negative 5's turn to come down. This is an additive inverse, a zero pair. We get rid of it. It's eliminated. We drop down the x. Negative 5 minus a negative 9. We're going to add the opposite. So we're going to add a 9. We're going to get a positive 4. And the degree of the remainder right here, this x, is now less than the degree of the divisor, x squared. So we're finished. And our quotient is x plus 9. And we can write it as x plus 9 remainder x plus 4. Or we could put this x plus 4 on top of our divisor, x squared minus 1, and say that our quotient is x plus 9 plus x plus 4 divided by x squared minus 1. See? Now, I know this can be really confusing. Now, the best thing I can do for you is back in Algebra 1, in 10.9a and 10.9b, it's going to be links to all of these videos in this description. There's going to be lots of links in this description. And all the previous videos, the 7 previous videos for this chapter that lead up to this video, they're all going to be linked in this description. All you have to do is watch them slowly. Start with this one, 10.9a and b, and then watch the previous videos for Chapter 6 in Algebra 2, and then re-watch this video and see if that helps, okay? At least watch 10.9a and b, and then this video again, okay? Because then maybe it'll make sense. I'm going to add this video to the Algebra 2 playlist. Our next video is 6.5, when we're going to talk about how to divide using synthetic division. Synthetic means fake, manufactured. So we're actually going to add instead of subtract to do division. So I'll show you how to do that. Now, I've said this before, and I even posted this on the JoAnn School Facebook page. It doesn't matter how many resources you have. If you don't know how to use them, it'll never be enough. Right at your fingertips, all you have to do is click on the links to these videos to understand what we just did, or to get better grades for studying, because all these videos are right there for you. And if you don't use them, and you don't watch them, or you skip some, there's nothing I can do. You know, the only thing I can do is make the videos to help you and hope that you'll watch them, okay? So keep your chin up. I think you can do this. It's very methodical. Just take one little step at a time and you'll be fine, okay? I believe in you. You can do it. Bye.